the things I love about visiting your training facility. You get to see where you normally don't. And by that I mean, here's a plenum, you get to see the A-coil for the air conditioning system. And I also notice a couple blue lights up there.
Yeah, the blue lights, those are actually UV lights that radiate onto the coil and the condensate pan to actually kill microbes that can grow on there, which does two things: keeps it cleaner, higher efficiency.
Well, another one of those add-ons, and we're going to cover a bunch of add-ons on a future segment, but right now I want to look at air conditioning systems, the different components that make them up, and really help the consumer select the right model for their situation based on that needs analysis.
Okay, let's think about that. We have the A-coil. What this does is it extracts the heat out of the indoor air. Also, it removes humidity, and that's what the condensate line does, is it actually drains the water that we wring out of the air and gets rid of it down through our floor drain.
So in the warm summer months, when I see water coming through that clear tube, it's a good thing.
That's a good thing.
Okay, you have some set up over here. They look a little different in shape, but are these also the coil?
Yeah, these are still an evaporator coil like we looked at, but with today's efficiencies, we have to also come up with a little different configuration to give us more heat transfer surface to get us a higher efficiency. This is an end coil. It happens to not have a casing on it because usually this is used for our retrofit market. In an existing furnace, we may be coming into somebody else's brand. It doesn't necessarily fit as a cased model, so what we would do is come in with an uncased, customize the plenum around it, and you're good to go. Whereas if we're going to be replacing a furnace and air conditioner, in most cases, they'll come in with a cased coil that physically matches the fit and finish and size of the furnace it's going to be sitting on.
Boy, and I guess to me that tells me that if I'm replacing my furnace, great time to consider replacing air conditioning. Maybe I don't have it, but my furnace is fine. I can still add it. I don't have to replace my furnace in order to get air conditioning.
Exactly. You don't have to do them at the same time. However, it does save the consumer some money due to the installation efficiencies of changing the total system all at once.
Makes sense to me. Now, when we talk about how a central air conditioning system operates, a lot depends on that blower motor continuously running. We've hit that throughout the series, talking about the importance for indoor air comfort, quality, and efficiency. Keep that blower motor going, but I assume it's important in the summer as well.
Exactly. The summer is as important as we talked for the winter mode for the heating season. As we know, hot air rises. Nobody can get away from that. So in the summertime, it's even more important that as we're running the continuous fan to do a couple things. One, there's a lot more pollen in the air. So by running the fan, it allows us to clean the air. Secondly, it helps balance the temperature in our home. So that hot air that rises, if we didn't run the furnace fan, it would stay up there until we finally had a call for cooling. What we would rather do is have that airflow continuously move around through the house. It may actually save you from having to run your air conditioning as often because it can take that cold air that migrates or collects in the basement, reutilize it and distribute it back throughout the remainder of the house. So it's a win-win that way. Clean air as well as less operation of your condensing unit.
It seems to me you'd end up with a cleaner indoor living environment too, because if there's dust suspended in the air, if that's getting circulated around, goes through your filters and you end up with a cleaner living environment.
Precisely.
Okay, so the key point for the consumer, you might have an A coil, you might have an N coil, maybe a different shaped coil. Bottom line is advancements in the industry are making them more energy efficient and making them much more comfortable in the long run for the homeowner.
Exactly. They've increased the comfort level that we can maintain for a homeowner based on the advancements in technology between the units too.
So essentially the coil takes care of the inside components?
Exactly. This traps the heat from the house, runs it through a set of tubing to the outdoor unit. And what this does, it sits outside and it expels that heat into the outdoor air. So we're taking the heat from inside, cooling the home, bringing it outside, expelling it into the outdoor air where it doesn't bother anybody.
Similar to a refrigerator.
Exactly. When you're standing in front of your refrigerator sometimes when it's running, you feel the heat on your bare feet. That's taking the heat from your food products, extracting it and pushing it outside into your room. Same thing goes here. We're taking the heat from indoors, bringing it through the outdoor condenser and expelling it outside.
Okay, what about efficiency? You know, in furnaces, it's pretty easy, 92, 96, 98.5% efficient. What about efficiencies when it comes to central air conditioning?
Central air conditioning in our area, or actually through the federal government, starts at 13 SEER. What does that mean? That means that we have an energy efficiency rating of 13. The higher the number goes, the cheaper it will be for me to cool my house. And the range right now is 13 all the way up to 21 SEER.
Okay, when we go up in efficiencies in furnaces, there's a considerable savings in energy. Am I going to see a payback with a central air conditioning system? Say I go from a 13 up to a 20?
You'll see a percentage savings identical. So if we were at 10 and we went to a 20, that would be a 50% savings when we look at SEER rating. So that's a lineal savings of electrical as we're cooling the home.
Okay, but here, let's face it, in the upper Midwest, we don't run it continuously a lot of the times.
Exactly. So in our market, there's a couple things that we really look at. If I, as a consumer, have indoor air quality issues where I'm really affected by pollen and dust and things like that, I may never open my windows. I may go right from running the heating in the wintertime and transition to air conditioning in the summer. It would then be much more important for me financially to upgrade to a higher SEER unit. It's going to save me money, and I'm running it for a much longer season than what another individual that may only turn it on in the hot months of July and August, they don't need it as efficient at that point.
And that makes great sense if you have health issues, if you have suffer from allergies, even humidity, because I know we touched on that these help with the humidity. Think about an 80-degree day here in the upper Midwest. A lot of times that doesn't sound like a lot of heat, but the humidity is oppressive. Air conditioner, if you're running it, you can do it more cost effectively if you have a higher end unit.
Yeah, that's a good point. The higher efficiency in that regard is going to save you money. When we say we're cooling the home, we also dehumidify, and that's a major factor in being comfortable indoors. 75 degrees and high humidity feels a lot more uncomfortable than 75 degrees with a constant 50% relative humidity inside.
Yeah, in the winter it's bad to have a cold room in the house, but I don't like that clamminess that comes with those really humid days. So with a high efficiency air conditioner system, I can efficiently create a comfortable living environment. Now over here there's a smaller sized condensing unit as compared to this one here. Is it just based on the size of a house?
Two things go into that. These are actually relatively close in same capacity, but there's a difference in their efficiencies. This is a 13 SEER, this happens to be a 16 SEER. Another thing we have to consider is what are we doing within those cabinetries. This is an entry-level model, so it's going to be an on-off 100% output when it runs. The advantage of this model as well is it brings us two-stage capacity through the compressor. Again, it's an upgraded model. The importance of that is we go back to that 80-degree day comparison you mentioned. This unit would run for a much shorter period of time, not being able to extract as much humidity out of the air, which is important on that high humidity, relatively mild day.
Sure.
This unit can run at a lower speed, lower capacity, wringing more moisture out of that indoor air, which is going to make us more comfortable, and it's going to get that humidity out of the house, which is really what we desire.
So those are some great factors to consider from a consumer standpoint. Don't just necessarily run out, get the higher efficiency or the lower one based on price. Think about your living environment, your situation, back to that needs analysis again that you've created with your contractor. Let's say that I'm looking up at a 16 or a 20 SEER unit. Are there any other options that I should be considering at that point?
Yeah, there's some advancements, especially in the heat pump side, getting into full variable capacity compressor as well as fan.
And a heat pump, of course, can not only cool, but heat your home.
Exactly.
Well, with all the advancements in that, that's room for another segment. We'll cover that at a later date.